Hello friends, this time our review is about an affordable graphics accelerator based on GPU AMD Captivate Pro with GDDR5 memory and an active cooling system. Graphics card AMD Radeon R7-250 is on the market since the end of 2013. It is a low-cost solution for entry-level systems. Initially, there were two modifications based on graphics core AMD OLED XT, which differed in video memory type, GDDR3 for the more affordable option and GDDR5 for the more expensive version. In the present review, we shall consider the upgraded modification of R7-250, which is already based on AMD Captivate Pro. This graphics processor is well known with regard to graphics card Radeon HD 7750. Taking into account Captivate Pro specifications, the performance of this model should be only slightly inferior to the more expensive AMD Radeon R7-250X, and we're going to test this in our review. The model from SAPPHIRE is supplied in a vertically oriented box made of cardboard and decorated with informative printing of the key advantages of graphics card. First of all, it regards to the increased number of stream processors. The box includes just a CD with drivers and software. It's no wonder since it doesn't require an additional power supply, and an analog monitor is connected by means of DSAP. SAPPHIRE Radeon R7-250 2G-D5 is made on the original circuit board of black color. As you can see, the layout of the key components is quite standard. The graphics core in the PCB center is surrounded by video memory chips, while the power subsystem components are located on the both sides. The power supply is carried out by a four-phase circuit. The crosspoints implement reliable solid capacitors, ferrite chokes and MOS transistors Fairchild, with low resistance of open channel. The video card is based on graphics chip AMD Captivate Pro. It is produced according to 28nm technological process and includes 512 stream processors, 16 rasterization units and 32 texture units. Its clock frequency is 925 MHz. On the other hand, the original CAD on OLED XT runs at a higher frequency of 1050 MHz. The memory with a total capacity of 2 GB is assembled by means of 4 Elpida chips that operate at an effective frequency of 4500 MHz. The data exchange between the graphics processor and the memory is carried out through a 128-bit bus, which has a bandwidth of 72 GB per second. The memory of the original reference version operates at an effective frequency of 4600 MHz, and its bus bandwidth is 74 GB per second in round figures. The image displaying is implemented by means of the reference set of interfaces DIV-ID, HDMI and DSAP. The total length of the graphics accelerator with the installed cooling system, which occupies 2 expansion slots, is 175 mm as measured in our lab. The cooler consists of the all-metal heatsink with ribbon, which promotes heat dissipation efficiency, and a 75 mm axial fan mounted on the plastic cover. The propeller is made by Upistec and is based on a sliding bearing. As you can see, the cooling system contacts the GPU by means of a thin layer of thermal paste on the radiator footing. The graphics core heated up to 61 degrees by automatic controller on the fan speed and under maximum load. The cooler was working at 40% of its maximum power and the noise was fairly quiet. Under no load, the graphics core and memory frequencies automatically go down. This promotes reduction of their power consumption and heat dissipation. In this mode, the GPU temperature did not exceed 36 degrees, and the generated noise level was rather quiet. In general, the cooling system showed a fair performance. It ensured comfortable temperature readings and featured a low noise level during everyday operations as well. As expected, Asus R7-250 OC2GD3 yielded to this model by an average of 40%. The key reason was the GPU changeover and implementation of GDDR5 memory, and HIS R7-250XA cooler got ahead by an average of 13%. Such result was achieved due to the greater number of stream processors 640 versus 512 and texture unit 40 versus 32. In addition, the high clock frequency of the GPU 1000 versus 925 MHz also made its contribution to this effect, and the only advantage on the side of SAPPHIRE Radeon R7 250 2GD5 is just an increased capacity of the video memory. As for the models from NVIDIA, modification of GeForce GT 740 with 2GB of GDDR5 memory got behind by 13.5% on average, while Genwood GTX 750 2GB golden sample got ahead by 60% on average. It's not surprising if you take into account the price difference in $25–30. As a result, the processing power of SAPPHIRE Radeon R7 250 2GD5 is at a fair decent level for its price segment, which is approximately $100. The new product copes well with modern multiplayer projects at medium graphic settings and at full HD resolution. As far as large resource-demanding games regard, then you will either have to minimize the settings to the lower level or to reduce the resolution. And if you require the higher frame rates in games, even not at the highest settings, then you may consider modifications of Radeon R7 250X with 2GB of GDDR5 or GeForce GTX 750. By means of MCI Afterburner utility, we managed to increase the GPU frequency from 925 MHz to 960. That made an increase of 3.8%. If we could increase the supply voltage, the result could be more significant. We managed to overclock the video memory from 1125 to 1465 MHz. The gain made slightly more than 30%, which can be called a good result. During overclocking, the fan speed was fixed at the maximum level and the GPU temperature was 57 degrees, which is a pretty good record. The average performance gain made 8.7%, which ensures a slight reduction of the backlog margin from NVIDIA GeForce GTX 750, although the latter is still the undisputed leader in this comparison. SAPPHIRE Radeon R7 250 2GD5 is an example of a specific modification of Radeon R7 250, which is based on graphics processor AMD Capewet Pro instead of conventional OLED XT. This changeover resulted in the increase of stream processors from 384 to 512, texture units from 24 to 32, and the raster units from 8 to 16. Formally, we did not have an opportunity to test the version of R7 250 on the basis of OLED XT with 2GB of GDDR5 memory, and it's rather difficult to be so definite about the advantages of such approach. However, the lack of 250 with 2GB of GDDR3 memory reached 40% on average. Therefore, indirectly, we can consider a positive effect resulting from implementation of the new GPU in 10% only. And if we compare the hero of the review with other competitors, then it was able to get ahead of its main opponent, NVIDIA GeForce GT 740, by 13.5% on average and reduced the backlog from R7 250X up to 13%. That is, this model is doing well with relation to the direct competitors, but if you get approximately $25–30 extra, then you may just count on much more powerful GeForce GTX 750. Therefore, the matter of choice depends on the priorities. The model from SAPPHIRE allows you to run even resource-intensive current games at Full HD resolution, but with low graphics setting mostly. If you can do with this, you can save the money, if not, you will have to pay extra. Best regards to you, and do not forget to subscribe to our channel. Bye bye.